One of the best way to study geometry is to add what you already know. We know this, that in a right angle triangle, if here is 90, so a squared plus b squared equals c. Now let's add that knowledge to this. If we divide this angle into 2, so that here is 30 degrees, we are the one that put 30 degrees, this one automatically becomes 90. Why? Are you here with me? Why is that place 90 degrees? No. First, where we started, we have only equilateral triangle. Don't have right angle. But we say, let's divide this angle here, this 60 degrees, this angle at A. Let's divide it into 2 equal parts. We divided it into 2 equal parts. So one part is 30 degrees, the other part is 30 degrees. So this place now becomes 90. I want you to come up with a superior reason. Is not a right angle triangle. What we have is an equilateral triangle, right? But it had become, or part of it had become a right angle triangle, right? So I want you to come up with a superior reason, not just to say, oh, it becomes a right angle triangle. See what we come. See, let me clean this. Let's see what we started with. What we have here is an equilateral triangle, right? What we have is an equilateral triangle. So we started first with an equilateral triangle. So that is what we have. Right now, what we have is an equilateral triangle. Equilateral triangle simply means. Now, we can also say is if here is 2, all the sides are also 2. If it's 4, it's 4. It's 3, it's 3. But then we decided to bisect this line. Bissection is dividing this line, bisecting this line. And if you continue to draw this line, it will join at BC. But here now had become 90 degrees. Remember, we divided this angle into 2. It's 30, 30. So why is here 30? Why is here 90 degrees? +60 plus 30, 90. When you are answering question, especially when you are answering data comparison, you have to first start from, you have to give the basic things, the axioms. You have to give the axioms the first consideration, right? You see this, the previous page, that all interior angles of a triangle is 180 degrees. Because we have divided this angle into 2, we don't necessarily know at what point it will meet BC. Stop here. But because we know that 60 and 30, if we have 60 and 30, so the remaining one is 90 degrees, right? So it's now a right angle triangle. But if we say it's 90 degrees because it's a right angle triangle, not what we started with. What we started with is an equilateral triangle. Okay. If you are looking at this, you'll have noticed that here is 60, here is 60, here is 30, here is 30. This is a type of triangle we called congruent. This is a congruent shape. In congruent shapes are shapes that are equal. They are equal in all respects, both the angles and the lengths. So we can also say that here is 1, here is also 1. Then we can use Pythagorean theory, we know already, find S. S being the distance from A to BC. We do that, we notice we do 1 squared plus S squared equals 2 squared. If 1 squared plus s squared equals 2 squared, what is s? Yes, I just want you to work it out. Leave it as root. So s squared equals 3 and s equals the square root of 3. So that is how we derive. Is what? But you said 2 squared. Squared is 4, is that not? What is there is 2. S equals the square root of 3. So that is how we derive this. 1 root 3 2. Similarly, we can derive this one when we say that here is 45 degrees and here is 45 degrees. Automatically, here is 1. Sorry, here is 1. Here is automatically 1. When we use Pythagorean theorem, say 1 squared plus 1 squared equals s squared. When we solve this, we get that s equals the square root of 2. So this is 1 root 2. Oh yeah. But look at this example. There is also an example here, which is example, if short side equals 5, then we find the rest. But look at this one. If one of the leg here will be one of the shorter side equals 7. One of the leg equals 7. What is the longer side? Remember what he's saying. If we put 7 here will also be 7. And because we got 1 times root 2 is 1 times root 2 is root 2. 7 times root 7. That brings us to the end of this page. And we move on. Okay, but look at here. It says diagonal of a square. Side times root. What does that mean? Multiply what? Of a square, right? This is what it's saying. Remember, this is a square. Diagonal is this long side. Diagonal is this long side. Of course, if here is s, so here is also s. And because if here is s, here is s, then this place is s root. So that's why the diagonal of a square is side times the square root of 2. Okay, don't forget that this 45, 90, if we complete this one, it becomes, we join this thing, it becomes what? It becomes a square. Okay, so these are the things we already know. Areas of a circle, pi r squared. Then circumference. Arc is part of the circumference. That is why length of arc is theta over 360. Then we just added 2 pi r. Sector is part of the area. That is why area of a sector is theta over 360. We just added pi r square, which is, remember, area of any volume, the formula of volume is base area times height. That is why the volume of a cylinder is pi r squared, which is the base, a circle, times h. Surface area. There is no such thing as area of a cylinder, but we can calculate the area of the surfaces. At the cylinder, we have 2 surfaces that are circle. So we have pi r squared, then plus 2 pi r h. A lateral surface, also called a curved surface. Okay, polygon. This is everyday thing. trapezoid, also called trapezium. Parallelogram, base times height. Also remember that parallelogram is the main mission, the main is the main basis of most quadrilaterals. For instance, rectangles are also parallelogram, and we already know that squares are a rectangle. We know how area of a square is s squared, because it's actually a side times side, which is side square. Can we move to another page? Vertical angles equal when two line intersects. Supplementing angles add to 180. Complementing angles add to 30 degrees. I think these are something we can briefly read. Remember this when line intersects. So we have A, B, C, D, E, F, H. What's happening, like say A plus B is 180, or A equals C and B equals D, are what we call axioms. They are axioms. These are basic things to give them preference before you start considering other things. But when we now say that line M, I call it line M and line N, like in that case, if they are parallel, that is M is parallel to N. If M is parallel to N, for M parallel to N, so for M parallel to N, then we start having other relationship, like A equals E, A equals E, because they correspond, and E equals G, because they are opposites, and G equals C, because they correspond. So B equals what? B equals F, right? F equals H, and H equals D. Okay, so I know most people are running. I've tried to combine two of the books we are using together. If you go to Manhattan, you also see most of these questions there. If the hypotenuse of an isosceles right triangle is 12√2, what is the area of the triangle? Can you try? You are trying it. But can you sketch it? Remember, yes. What do you say? You say pi. This is a isosceles triangle, so nothing concern it with pi. Huh? Yes. We have all that. So we have, me and you go fight. So look at it. We have passed there. This is that what they are saying? Is this thing you are saying? Is this one here? Is isosceles right angle? Is not what he said. Didn't it use the word isosceles right angle? Because the only thing that answers isosceles, the only triangle that is isosceles and right angle is the one. First, let's combine them. This is a combination of two set of things. We already know that isosceles means two sides are equal. True of us. Now, right angle triangle means at least one of the side is 90 degrees. Not at least. It can't even be that one of the side is 90 degrees. So it is this one here. Is this special triangle 45, 45, 90 is the triangle that is called isosceles right angle triangle. The only triangle that is both isosceles and right angle triangle is 45, 45, 90. And once you are seeing it, you quote this formula: 1 1 root 2. Okay, 1 1, so 1 1 root 2, right? So it is 1 1 root 2. Okay, let's go back to the question. Before we continue, I want to ask you a question. If we have 30, 60, 90, what will be the ratio? The first one is 1, okay? How about the rest? Root 3, right? Root 3, not 2 3. Like this. Okay. And 2. And 2. I want you to just spend just 30 seconds. Look at it again. They are important. These are the only ratio that will ever be given to you. Even when you hear special triangle, okay, it means special right triangles. Only this is only this. Okay, even for this one, what I wanted to add, if you ever start with an odd number, let's say the odd number 5, when we say 5 squared minus 1, 5 squared minus 1 divided by 2. 5 squared is 25 minus 1. 24 divided by 2, that is 13. 5 squared plus 1 divided by 2. 25 plus 1, 13 divided by 25 plus 1, 26 divided by 2, 13. All that is a formation of Pythagorean triple, starting with the odd number. Okay, but you see these two formulas, so they are essential. I'm not saying that they must ask a question based on this, but they are essential. I don't know if you have looked at two of them now. Can we proceed? If you go to a triangle, if you know this, what is going through your mind is, if the hypotenuse, what we go through your mind is 1 1 root 2, and they say the hypotenuse, which is 12, 2. So here is 12, 12. Now, with this information added, can you find the area? Of course, this one will be the base. One of them will be the base. The other one will be the height. So you remember that GRE, they will hardly say in a isosceles triangle, if the base is 12 and the height is 12. If the base is 12 and the height is 12, find the area. So that is making it look so easy, right? Right. But so this is what is it? Just know that what the base and the height is this and that. If you now know it, that is the base and height, can you find it now? So what is the area? Yeah, 22. Yeah, 144 divided by 2. Okay, 72. A circle has equal. A circle has area equal to its circumference. What is the radius? You can also solve it. Give it a try. So you don't know? Hello? Solving it together is not a problem. When you see a question, right? When you see a question, try to jot down all you know about that question. As you jot down, the answers will start connecting. The answers will start connecting. The answers will start connecting gradually. Okay, so the answers will start connecting gradually. Start from this. Okay, so let me ask you. A circle has area equal to its circumference. What is the area of a circle? It's pi r squared. Pi r squared. No. Yes, pi r squared. Pi r squared equals, the circumference is what? Yes, pi d, also 2 pi r. Yeah, equals 2 pi r. That is what the question is saying. And you solve it from there. Just a little thinking, just a little looking at the question, or looking at it and see if there's something common. Hello? Is there now? Pi can cancel pi. You don't need permission. Pi can cancel pi. Okay? Pi can cancel pi. Yes, pi can cancel pi. So what else? Look at it again. You see that there is something that you can do. Hello? That thing is r now. R squared equals r. Right? If you have r squared equals r, that means you. Oh, thank you. Yeah, divide both sides by r. If you divide both sides by r, what will remain? Yes. Just cancel r first. So the most logical choice. If you cancel r, what will remain? If you if you cancel r, so you are going to have r equals 2. But go back to that equation and try use 2. All right, say when the radius equals 2, you try that formula, find the area and also find the circumference and see whether they are equal, right? If they are equal, that means the radius you found is correct. Just try it now. Remember that you don't need to solve all the equations because they are all similar. If you can understand something or a little thing, then you can expand it. Have you confirmed? Okay. So let's look at the next question. The center of a circle is 10 minus 3. That is, x is 10, y is minus 3. Point 10, 9 is outside. Point is outside the circle, right? And yeah, point 0.6, minus 3 inside. If the radius is an integer, how many values are possible? Okay. How many values are possible? First, we need to sketch this, knowing very well that is the, oh, I don't know whether there is a space to do. So this is maybe let's try something like this. That this manage here. So where is we can, so we can try we can try sketching this, right? This is not totally very easy. Okay, so but where is 10 minus 3? See that this is too small. To get 10 and minus 3, this is this diagram will not work. I mean, we will have say here is 10 first, and here is minus 3. Okay, so that the point we are looking for is around here, but that is also a little problem now. If we make that center, unless we want to draw a smaller version of a triangle here, just manage that. Just manage that place as just manage that point now as a center of the circle. What else that is there? 10 and 9. So what is the meaning of 10 and 9? Or even that diagram I sketch is that even that circle is wrong there. I've forgotten. So that place is 10 and minus 3. Okay, is s that is 10 rather. So minus 3 would be minus 3. Let's just say something like here. Okay. The next one is 10 and 9. Point 10 and 9 is outside. Remember, the very good thing is it has the same thing, the same 10. The same 10, that is a vertical line. So a vertical line here. okay, that one is no longer useless. So, like here is 9. But they say that that point is that point is that point is outside the, so that point is outside the circle. And minus 6 and minus 3. Remember, the one we had before is, we had okay, so the y had also not changed, the minus 3. So it's still like minus 3 somewhere here is inside. Yeah, maybe somewhere here is inside. But if you wanted to be a little more accurate with this diagram, we can make it bigger, of course. Yeah, maybe make it yeah, bigger than this. All right. So the question is saying, when we have sketched this, it's asking, if radius r is an integer, how many values are possible? Okay, we have here, we know all the points. We know this point, right? This point is outside, okay? And this one is inside, not necessarily the line. This is minus 3. And this is 9. This is a type of what we are doing yesterday, but in the way the ETS people set it. So this place, we know here. Let me label them. The center is 10 and minus 3. And this other one, the one inside is 6 and minus 3. 6 and minus 3. This point from 6 minus 3 and this other point 10 and minus 3. What is the length? Are you there with me? You know, it is the same line. It is the same horizontal line. So one is starting at 6. The other one is starting at 10. So one is at 6. The other one is so the other one is at 10. But it's the same horizontal line. Because it is the same horizontal line, we don't really need to use that distance formula. Remember the distance formula? I don't know if you still remember. The distance formula is this. D equals the square root of S2 minus S1 squared plus what? Can you remember? Y2 minus Y1, right? Hello? So Y2 minus Y1 all squared. But if you apply it to this one we are solving, it will still work. But that will be a waste of time. It's just a waste of time. These lines, so these lines, right? This line is a horizontal line. So along horizontal line, we can just subtract, right? Between from 10 minus 6. I'm asking 10 minus 6. I know I'm not asking you that is the hard thing, but it's just to make sure, because I'm not also seeing you, I'm only seeing my screen, right? That will also help me. My network. 10 minus 6. 4. So this place is 4. If you look at this line too, both of them are 10, 10. So since both of them are 10, 10, 10, 10, right? So both of them are 10, 10. That means this is actually a line. I think I was trying to say this yesterday. A vertical line like this, the line, this is a particular, this is a line of s equals 10, all of this line. Okay, but at this particular point, we also have, the question said is 10,9. So this is a vertical line. We can just do a normal, we just do a normal, normal subtraction. 9 minus minus 3. Okay, so 9 minus minus 3 is no, 9 minus minus 3. Did you say 3? See what I'm saying? No, 9 minus minus 3. Say is what? Nine minus minus 3 is 9 plus 3 now, is that not? Minus 3 minus 3 is minus 6. Minus 9 minus 3 is minus 12. 9 minus minus 3 is 12. Okay, these are basic things, you see. This will not, this alone will not solve this. Okay. For this question we are solving too, you can go to Manhattan and find them. You see, in Manhattan is under Miss this particular question missed. You can also find maybe the Manhattan people also solve it. Let me look for question number. Let me look for the question number. Because I know we can't finish all these questions. Like this particular one, all of them are written like say where, oh, so their sources are there. Okay, that is Manhattan LB, page 145, 114. 159. Okay, so this is that particular question we are solving now. So this is the particular question we are solving. Yeah. Also, these ones are the more authentic. Maybe trying to compile them together. Maybe there could have been losses. So you can also come here and more related. But before we go back to that page, and continue what we are doing, look at this. If the area of the circle is 36 pi, and the area of the rectangle is, what is the length of this? Wow, this is harder than what I'm thinking. Okay, let's look at this together. Let's quickly solve it and go back to where we are. But let's do this together. First, it said that if the area of the circle is 32 pi, that means we set up our area first. Pi r squared equals 36 pi, of which pi we cancel pi. R squared is 36, so r equals 6. Remember, when we are, let's say you are looking for area of a triangle of the area, since today we have not been talking something about plus or minus 6, because the length of something cannot be minus. I mean, distance cannot be minus. Okay, let's go. Are you here with me? Are you still connected? All right. What is AO? Are you seeing AO? What is the distance AO? Are you really there? What is the radius? What is the radius? So tell me now. I think we have found the radius. What is it? The radius. Look at the radius now. We have found it as 6. That. Okay. So what is AO? I'm recording it. You know that recording might not be perfect, but yeah, I'm recording it. So what is AO? Okay, let me just assume it's network. AO is the same as radius, but AO is also one of the sides of ABCD, and the area of ABCD is 72. So we can say AO line AO times line OC equals 72. This OO is 6. So 6 times line OC equals 72. OC equals 72 divided by 6. I think 76 divided by 72. 6 times 10 is 60. 6 times 12 is 72. So OC is 12. AB is also 12. But what we are looking for is DC. Then we say that DC equals 12 minus 6. Since OD is 6. So that equals 6. So we can actually put 6 there. All right. I think we can go back. So this is the topic. What is covered supposed to be able to solve all these questions. Yeah, supposed to be able to solve all the questions. Let's go back to the one we are solving now. Okay, so we are back here. We have calculated this base as 4, and we have calculated the base of this triangle form as 4, remembering that 6, minus 3 is inside the circle. What this actually mean? What this actually mean? What this actually mean is that this is inside, meaning that this 4, the length of the radius must be greater than 4, since 4, this length 4 is inside the circle, so it must be greater than 4. We now need to find the upper boundary. What is the upper boundary? You notice 9 minus 3 is 12, meaning since the radius is an integer, it must not be up to 12, since 12 is outside the circle. So the length of the radius, that is number 4. The radius we are looking for must be greater than 4, so it's between 5, 6, 7, 8, 9, 10, or 11. So these are the numbers. So it can be only these numbers. Unfortunately, there's no even option here. I think the original question, right? The original question included options. But let's count and see how many of them. 1, 2, 3, 4, 5, 6, 7. It can only be only 7 possible values. How many values? So only 7 possible values. Okay. Go back on your own and try the remaining. Let's go to the next thing. Oh, the answers and explanations are even here. All right. Oh, I didn't know. Okay. Yeah, coordinate geometry proper. And in coordinate geometry, so we have quadrants, the quadrants of a coordinate geometry. Okay, but who cares? The distance between the distance between 2 points is given as this. What is the distance? What is the nature of what this means? Let's say we have this, and we have a length like this, So the distance between these 2 points, let's call it point P and point Q, can be solved using this formula. So here is this. There is already an example here. So in solving this, how did we arrive at 6? 4 minus 2. Also 6 minus 2. Of them 8. 8 c squared and 8 squared. Then we find the square root. The midpoint value, just the middle of the coordinates. So 1 plus 4 divided by 2, 2.5. 1 plus 3, 4 divided by 2. Okay, slope is changing y over changing s. And also other things that we can add. Look at this, something like this. These are the positive slopes. And the better thing to do about negative and positive. Let's say positive slope is the one both s and y increases, and negative slope is the one s increases, y increases, vice versa. Equation of a line. So this is a very popular equation. Okay, this is also another equation. The main purpose of this one is to even formulate the equation of a line. But for now, we're supposed to know that m is the slope and b is the intercept on y-axis. When are two lines parallel? Two lines are parallel when they have the same slope. For instance, y equals 2s plus 3 and y equals 2s minus 10. Y equals 2s plus 100. All these are parallel because they have the same slope. They are parallel because they have the same slope. Two lines are perpendicular. Perpendicular simply means 90 degrees. But we want to say it when their slope, if we have y equals 2s plus 3, the line that is perpendicular to this will be minus half s minus anything. Doesn't matter. But 2 times minus half is minus 1. This question says line J and K intersect at 1, 3. Line J, y equals AS plus 10. Line K, y equals BS plus A. Find B. What does intersection mean? If two lines intersect, then they are equal at that particular point. So if you have this, what we'll do is to equate it. Yeah, because the it said the line J and K intersect at 1 and 3. So that is the point of intersection. When we draw this line, the line of y equals AS plus 10, and the line of K equals and the line of K, y equals BS plus A, they intersect at the point 1 and 3. Another way of viewing it is that the point 1 and 3 is on both lines. That is, when for this first equation, when y is 3, A is 1. And for the second equation, when y is 3, A is also 1. Then we can solve for A and B. Just also remember, I know some of us, I think we are more, most people can solve simultaneous equation. When you solve simultaneous equation, the answer to that simultaneous equation you are solving is actually when those two graphs or those two lines meet. Then here comes the equation of a circle. One thing that you must note in this equation of a circle is that you can put it side by side with this. This is s2 minus s1 all squared plus y2 minus y1 all squared equals this squared is the distance between points. What we are calling equation of a circle is just distance between 2 points. Like the distance between this center, this uses h and k, this center hk, and on the circle, on the circle uses here s and s comma y. So this is a fancy name of radius. So change b to r, that becomes equation of a circle. Then we go. Yeah, see about complete the square, about see what we are seeing here is just two quadratic equations. It would have been better to spend a little time doing quadratic equation first. Yeah, the vertex form of a parabola. A parabola is just this, like this, maybe this, right? So when you just it's a fancy name of if you graph a quadratic function. The vertex form will be the turning point, the value at the turning point, and parabola. The vertex form simply means we want to write this so that when we are looking at this now, k is the value of y at turning point, and minus h, because it's minus it will be plus, if it is plus it will be minus at the turning point. All right, so these reflections, yes, over s axis, over the y axis, when y equals s and when y equals minus s. We can always try some of this when you set an up and equation So you just change the values. So you change the values of the coordinates. The coordinate where that's supposed to be AB, change it to A minus B. So that's you have you get the Y coordinate, you get the S coordinate. Remember, it's just saying you have these 2 points. Put array. It's when we said over the Y over the S axis. So it simply changes. 2 will still be 2, but this change to -3. Then you graph it. Okay, so collinear is talking about several different points with same slope, but this is already getting a little far. Okay, so let's look at this now. Okay, the triples, we have already talked about the triple before. These are also the list of things you should never do. Y1 minus Y2, for instance, over S2 minus S1. What is this actually saying? It is saying that what we reference to S2, this is the correct order of things. If you use 1 here as S1, Y1 must be there. If you use another point as S2, Y2 must be there. So they must always be together, not in different places. So some other errors also avoid. Then here are exercises for you. What is the slope of a line through -4/5, -4,5, and -4,5 and 1,2? Remember, changing y over changing s. By the way, if you are looking at this slope, is it a negative slope or a positive slope? From -4 to 1 is an increase. From -4 to 1 is an increase. And from 5 to 2 is a decrease. So this is a negative slope. Then you can start, because it's a negative slope, it must carry negative. Then you can start looking at the absolute change. The absolute change from 5 to 2. Absolute change from 5 to 2 is 3. Absolute change from -4 to 1. From -4 to 1 is 5. From 5 to 2 is 3. So that's supposed to be -3/5 as the answer. But this will save you time. If you want to solve it all, you're going to say the slope equals -5 over 1 minus -4 equals -3/5. So -3/5. So a good number of questions for you to try. Even the solutions are provided. Also, most of these questions, you see that they are like this one is written Manhattan Prep, because it's written Manhattan Prep. You can also go to that book. I've already shared the book. Check these questions. But this will be much better to check it with the book. It's not really about giving formula sheets, cheat sheet. So the formula sheet is there again. I think we shared one before. The most important thing is walking through them and committing memory. One thing that we have seen here that demands attention, I don't want to start delving into something that can bring confusion, is the vertex form of a parabola, which we can easily get using quadratic equation. Let me even give you an example of what it is saying. If we have s squared plus 6s plus 10. But even this, let's find something that we can solve. Let's really find something we can solve. 6 is 2 and 3. 2 times 3. Let's use 5, something that we can really solve. So if we use 5 here, this equals 0. Agree with me that when we solve this, what we multiply to get 5 and add to get 6, in as much as the coefficient of s squared 1. So here we can put s plus 5 and s plus 1. 1 times 5 is 5, 1 plus 5 is 6. So here s equals minus 5 or s equals minus 1. All right, when you are saying this, so you are solving this, but the vertex form we are talking about is, let's say we have this s squared plus 6s. What we can add to it, make it a perfect square, is half of 6, the square of half of 6. Half of 6 is 3. 3 squared is 9. So we are going to add 9. When we add 9, we subtract 9 again. Then put 5 where it was before. When we solve this now, it will now be, because 3 times 3 is 9 and 3 plus 3 is 6. We have s plus 3. 3 times 3 is s plus 3 twice. So s plus 3 squared. Then we have minus 9 plus 5. Minus 9 plus 5 is minus 4. Vertex form simply means that when we sketch this graph, maybe we sketch this graph, already it will pass through 5. It will pass through minus 5 and minus 1. It's going to turn at minus 4. And the value of that place, 6 plus 3, is going to be minus 3. So that this is going to be something like this, where this place minus 3. That is just all. That is all. That's all the noise about. All the noise about vertex form. So that place is minus 3. All right. 2 more pages. So we have additional practice at Khan Academy. Here's official prep. GMAT Club Forum. Khan Academy and GMAT Club Forum are websites. I've also included here website. So I also included glossary of the of terms. Okay. I think the harder part is the time is the time for us to go through this. We don't have this material, so let me know. I will send it. All right. Are you still there? Okay, the thing is, first, going the question, the theories here, they are still the theories, but although a little more expanded than what you can get from the official guide. But if I say the Manhattan, the other formula sheet which I shared too, these are all kind of that are still the same thing. But questions are hardly, yeah, questions are hardly straightforward. Yes, questions are hardly um straightforward. Okay, but when you see a question, not that you must get, not that you must be able to solve all the, start solving it and start asking, okay, is there anything that can? And I know geometry. Geometry is my favorite, and this geometry I say only few things, because all the things you are saying are connected. Connected means one thing is leading to that thing. Like in finding the volume of a cylinder, that is the base area times height. The cylinder, the base is a circle, no other base. So, or pi r squared, or the base area height. You are in. And in the exam, they will hardly say something harder. That's too hard, that you cannot solve if I remember this one. All right, I will check if the recording didn't go through, or that means I might need to present the I will need to do more I will need shorter presentation, maybe during one of the classes. So I will turn one of my upcoming classes, turn it presentation. Then but I hope it's record. Thank you. And what you do now is, especially for my hand that included a good number of questions, open it and see how many of them that you can try. Yes, you can always send me because that we are finding challenge. Thank you, and talk to you. That is what I'm saying. Once we are done with this, once I'm done with this, in like 2 or 3 minutes, I will let you know if recorded. If it's recorded, then I will process the recording. Okay, thank you. Bye.